Hello guys, I am Umesh Gajjar and today I will give you the brief idea about SolidWorks Plastics. Basically, SolidWorks Plastics simulates how melted plastic flow during the injection molding process. So it helps to eliminate the costly mold rework, manufacturing defects, and it will also improve the quality of plastic parts. So first we will make one plastic part and then we will carry out SolidWorks simulation on it. So first click part, new and OK. First we will convert it into MMGS system. Select any plane, put it in a normal way and then sketch a rectangle. Give it dimension, say 100 mm by 100 mm. Click OK. Go to the features, extruded bows, thickness 10 mm. Click OK. Now we are going to make 4 holes on it. So just draw the center line first. And draw the circle, give it dimension, say 10 mm diameter, and the distance between the center line and the center of circle, say 25 mm. Do the same thing again. Now apply the mirror entities command from here. Entities to mirror, select this circle, mirror about, select this center line, click OK. Do the same thing again. Mirror entities, entities to mirror, mirror about this center line, click OK. Go to the features and extruded cut, and here select through all, click OK. So you can see our part is ready. Now to add SolidWorks plastic in the our SolidWorks window, go to the SolidWorks add-ins and click SolidWorks Plastics. So it will be added in the system. You can see it from here by just clicking it. We can also add the SolidWorks plastic from tools, then click add-ins and then activate SolidWorks plastic, but we already activated it, so just click OK. Now to carry out the simulation in SolidWorks plastic, we have to follow the 4 procedures. First we have to generate the mass, then second we have to assign the material to the plastic and to the mold. Third, we have to assign the process parameters such as injection pressure, mold temperature, melt temperature, and in the fourth step we have to assign the injection location and air vent location. So first we have to generate the mesh, but you can see from here the mesh has been not activated. So first we need to save this part to activate the mesh. Okay, and then just save it. Now you can see the mesh has been activated. Now go to the display manager from here and just click it. So from here you can see we have two options. Either we can go with this solid mesh or we can select the cell mesh. The solid mesh represent the whole body. On the other hand, the cell mesh only represent the surface area. So definitely we will go with the solid mesh. in each mesh we have two options. Either we can use the auto mesh or manual mesh. So in this case we will apply the manual mesh. Okay, so click next. Then here it will ask you the element size. So we can change it from here, and as you can see, if you will change the element size, then the number of elements will definitely change. If you will decrease the element size, then definitely the number of elements will increase. So say we want the element size 5 mm. Okay, and then hit mesh. So you will see there is a irregularity here. So we have to apply the local refinement. So we have two options. We can assign the size of local refinement, or we can use the automatic local refinement option from here. So we will select the automatic refinement and then hit mesh. So you can see the shape is now proper. So now you can see from here there is a gradation option. So if we select the sharp gradation from here, and if we will hit mesh, then you can see the element size will increase sharply from the small elements to the large elements. Okay, and if we will select the smooth, then the element size will increase smoothly from the small elements to the large elements. So we will use the smooth gradation. Click next, just accept it. Next. So it will ask you the solid mesh type. So we can use tetrahedral mesh or hexahedral mesh, but we will go with the tetrahedral mesh from here. Click next. Then in tetrahedral mesh it will give you two options. Either you can apply the tetrahedral mesh only, or you can apply the hybrid mesh. So we'll select the hybrid mesh and hit create mesh. So it will create mesh. Next. Okay, from here you can select the section clippings to see the sectional view. You can see from here there are 6 elements throughout the thickness. Now SolidWorks has one rule that if the elements will 5 or more, then only it will give you the good result of the flow, of the plastic flow. So we have 6 elements, so we are good. But if you don't have the 5 or more elements, then we have two options. We can either increase the thickness of the part, or we can apply the more elements throughout the thickness by maybe applying the local refinement here. Okay, or we can match the geometry with small elements. Just hit OK. Now you can see the mesh has been generated. To activate it, just click the mesh model, so you can see the mesh. Now we will apply the material property. So first we will apply the plastic property, and then we will apply the mold material. So just click the polymer, just double click it. So you can see the n number of materials available here. Okay, and in each section we can see many materials. Okay, we can also sort it by company by just clicking the sort by company. Okay, just say we want to select this material, so click it. So you can see the different properties of this material, say specific heat, Poisson's ratio, then thermal expansion coefficient, thermal conductivity, and many more things. Say for this material the Poisson's ratio is 0.35 and we want to change it to 0.40, okay, and the other properties we want to keep it as it is. So for that, just copy this material and go to the user defined database, just paste it somewhere, say here, okay, and then we can change it by just right click and click edit, then go to the Poisson's ratio from here and change it to 0.4, okay. So you can see from here the Poisson's ratio has already been changed. Even you can define your own material from here, just click the add product and write product name and the different properties, say young modulus, thermal conductivity, viscosity, just assign it and hit OK. So it will be saved and you can apply it to our polymer material. In this case we will select the ABS polymer HS3D. So you can see from here our polymer product or say plastic material is Sculman polymer HS3D. Now mold material, so you have n number of mold materials, say pure gold, pure lead, pure silver, titanium, then copper alloys, aluminum alloys. So you want to select aluminum alloys 1060 alloy, okay, so just click it. If you want to assign your own material, then you can just go to the user defined database as we discussed before. You can also change the property for this material, just hit OK. Now process parameters, so in fill settings you can see filling time. So filling time is the time during which the melted plastic will fill through the mold, okay. So SolidWorks has automatically calculated it at 10 seconds, but we can change it by just clicking it and say 15 seconds, okay, but we'll keep it 10 seconds. Melt temperature say 250 degree, then mold temperature we will keep it as it is 52, but we can change it if we want. Injection pressure say 60 megapascal, okay. We can change the mold melt heat transfer coefficient from here, just hit OK. Then pack settings, say pressure holding time. So pressure holding time comes after the filling time. So when once the mold will be filled completely with the melted plastic, then it will be held for particular pressure for particular time, and it's that time called pressure holding time. And during the pressure holding time we can change the pressure profile from here. We have two options, either we can control it by absolute control or we can use the relative control method. So first, if we will select the absolute control method, we can see the time is listed here. The total pressure holding time is 15.73 seconds as we assigned here. So we can change the injection pressure for particular time, say 60 megapascal, then say 55, and so we can set for 6 second, 8 second, and so on. And if we will hit apply, then it will ask, because we assigned the total pressure holding time 15.73 seconds, so it is asking for auto adjust. So just hit it, so it will be auto adjusted. And in relative control, it will adjust the injection pressure relative to the maximum injection pressure which we assigned 60 megapascal, okay. So say 100%. Okay, so we can assign it, and if we'll have hit apply, definitely it will auto adjust. So hit OK, and then just click OK. We can also change the pure cooling time from here. Okay, the pure cooling time is the time comes after the pressure holding time. During this time the mold will be cooled without any external pressure. So first the fill time will come, then pressure holding time, and then pure cooling time. So total time will be the combination of these three times. Just hit OK. Then in field settings we can also change the mold temperature profile. Just say edit or show profile. So as I mentioned, the total time would be 110 seconds, combination of these three times, and then we can change the mold temperature accordingly. At 0% time the mold temperature value you have to assign, and so on. So it will show you the graph for that. We'll keep it as it is. Now warp settings. So in warp settings, if you will click, you can see the ambient temperature for the particular mold. So we'll keep it as it is, 30 seconds. And if we will keep it this plate horizontally, then we can see the gravity direction would be in negative z direction. So we will keep it negative z, okay, downward direction here, and hit OK. Then injection location, just double click, and we can add the injection location by just clicking particular node. So we want to add the injection location here, just click that node and click add location, so it will be added. Now if you want to automatically add location, then just hit automatically add location and click the number of locations which you want to add. So we want 2 number of locations, so just click 2. Okay, we can delete any injection location by just clicking it and select delete injection location, so it will be deleted. Just add it. Okay, hit OK. We can also assign the air vent location. Here the air vents are provided to let air or gap escape through the mold. Okay, so we will assign the air vent location at the corner of the parts. Just hit apply and click OK. Okay, so we define all the conditions. Now we can run the analysis. So just we will run the flow run analysis. Just hit flow. So it will take like 2 minutes to run the whole analysis, and then we will go through the results. Okay, so our analysis is finished, and if we'll go through the result, then the result advisor is telling that the part can be successfully filled with an injection pressure 0.7 megapascal. Okay, so the part can be successfully filled with the injection of 0.7 megapascal. Then it is definitely less than the 66% of the maximum injection pressure, because we assigned the maximum injection pressure 60 megapascal. Then it is telling that we can reduce the part thickness and decrease cooling time, but we have to be ensure that we have to run the another analysis after changing the thickness. So definitely we have to run the another analysis after changing the part thickness or decreasing the cooling time. Okay, now here it will give you the idea about different process parameters, say fill time, pressure at end of fill, temperature at end of fill, then bulk temperature at end of fill time. So the fill time is 12.5414 second. So during after this time the mold will be filled completely with the melted plastic. Then pressure at end of fill, temperature at end of fill. So maximum temperature at end of fill would be 244.72 degree bulk temperature. So if you want to get the idea about any definition, then you can just click it from here and you can get the idea about any information, say air traps, pressure at end of fill. You can get the definition for particular terms, and you can also get the procedure that how to change that particular process parameters from here. Just click cancel, yeah, or you can also get the idea about it from here. Okay, if you will scroll it. So say flow front central temperature, it will give you the idea about flow front central temperature. Okay, then shear stress, shear rate, volumetric shrinkage at end of fill. So it will give you the idea about the shrinkage in the volume of the part due to the cooling effect. So the maximum shrinkage is 10.61%. Freezing time at end of fill, then cooling time, and sink marks. So it will give you the idea about the depression on the part surface due to the cooling. So maximum depression is 0.0595 mm, and it can be seen from the red area. Okay, gate filling contribution. So it will give you the idea about gate filling contribution, that the green line indicates the area filled by the gate 1, the blue line indicates, or the blue shade indicate the area which is filled by gate 2, and the yellow area indicate the area filled by the gate 3. Ease of fill. So the green area indicate that the mold can be filled easily with the current injection pressure. The yellow area indicate the injection pressure needed to fill the mold exceeds the 70% of the maximum injection pressure, or say machining injection pressure. Then red area indicate the injection pressure needed is exceed 85% of the maximum injection pressure. Then frozen area at end of fill. So here you can see the green area indicates that the plastic is in its hard or say glassy form, and the red area indicates the plastic is in its still soft or rubbery form. Okay, then weld lines. So weld lines are the lines where two flow front will meet with each other. So it's the weakest area in the part. So we have to try to eliminate these weld lines. And their air traps. So it will give you the idea about the traps of air and gas. So at the location where the air trap is there, it will not allow the plastic to flow at particular location. So part will be like deformed at that particular location. Okay, velocity vector at end of fill. So you can see the velocity vector at the point of injection, it will be outwards definitely. So you can see from here, you can also see it from here. Okay, just click OK. And then if you want to generate the report of the analysis, then go to the summary and report and hit OK, and then give it title, say SolidWorks Plastic then date say 3/28, department say MMEE, and institute say IIT, author say Umesh Gajjar. And if you will hit OK, then you will get this type of report. So you can add your own introduction, then it will give you the different idea about the model information, say the name of model, then type of elements, okay, then weight of the particular model, the size of the model, then material properties for the model, say the melt temperature is 240 mole temperature, then filling time, mean melt temperature, mole temperature. Then it will also give you the idea about the flow results, say x direction clamping force, y direction clamping force. So the clamping force is the force which will hold the mold close against the injection pressure. Then maximum real temperature. That will also include the different flow results, say fill time result, then pressure at end of fill. Okay. It will also include the XY plot for maximum inlet pressure versus time, then inlet flow rate versus time, then X direction clamping force, Y direction clamping force, Z direction clamping force, and at the end you can write your own conclusion. Okay, so I'm done with SolidWorks Plastics. If you have any question, you can ask me on my mail ID. It's ugajjar@hawk.iit.edu. Thanks for watching.